All right, find the electrical field at point P. Notice that this is a negative charge. This guy's a positive charge, right? And we are 21 meters between these two, and we are 13 meters. Is what this is supposed to be interpreted, right? There we go. All right, so what we're going to use, the base equation here is that E is KQ over R squared, the electric field away from a point, right? This is not in the data packet. You must memorize it. Its equivalent in gravity is in the data packet. You can get it from dividing what Coulomb's law by one of the charges, okay? Or you can just memorize it, but it's not in there. It should be, in my opinion. All right, now, what we're going to do here is we are going to find the electric field due to, I'm going to call this guy A, I'm going to call this guy B, okay? The electric field due to A is going to be toward A, okay? So this is the electric field of A, okay? And the reason it's toward A is that it's always the direction that positive charge would start to go, okay? And a positive charge, of course, would go to the right because it would be attracted to the negative charge, right? And the electric field of B is going to be to the left. And of course, that's because we pretend there's a positive charge here. And it would be repelled by this, okay? So the electric field from B is away from B, right? In all directions. The electric field around A is toward A, right? Because positive charge would be attracted to A. Remember, toward negative charges, away from positive charges. That's by the way, one of the hardest things about these, right? Okay, now let's find the magnitudes of these. So the electric field of, I guess, A is going to be 8.99 times 10 to the 9th Newton meters squared per Coulomb squared. And then this charge is 2.3 times 10 to the minus 6th coulombs. Notice that I'm ignoring the minus sign because I think it confuses the issue here. I'm going to go 13 meters squared. I'll decide which direction it is after I calculate the magnitude. So I just ignore these minus signs. Now, if I was smart enough, there'd be some way that I could make a vector out of this, and I don't even know, right? But when I do them, I ignore the minus sign. Okay, so this is 8.99 E9. E9 times 2.3 E minus 6 divided by 13 squared. Don't forget to square. These fields all have squared r's under them, okay? We're going to look at things that look a lot like these fields, but they won't have an r under them. Okay, they won't have an r squared. Okay, so what do I get? I get 122.349, and then the way these units work out, meters squared cancel, one of the coulombs cancels, and we end up with newtons per coulomb, which is the units of electric field. Now, this is the electric field due to A. This is going to be, is it? Yeah, it is due to A. This is going to be to the right, okay? So I'm going to make this guy positive. I make things that are to the right positive. This is just what I do, my own personal way. If you've got a better way, then go for that, right? Okay. And the reason it's to the right, again, is that a positive charge right here would be attracted to that. Okay, so the force on positive charge is toward charge A, okay? And now let's find the electric field of B, right? That's going to be 8.99 E9 times 9.1 E minus 6, all divided by, and then what is this distance? What is 21 plus 13? I think that's 34, right? So we are 13 and 21 meters from it. We are 34 meters. This point right here is 34 meters, 13 plus 21, right? Meters from charge B, so 34 squared. Okay, I'm just going to edit this thing here. That's 34. The distance is 34, and the charge is 9.1. And I get 70.769. Okay, now, the electric field due to B is going to be to the left because the electric field due to this charge is away from it, and away from that charge at point P would be to the left. Okay, newtons per coulomb left. All right, so I'm going to make this guy negative. okay? This is my own personal thing. Now notice, you know, that I'm ignoring the sign on there. I'm just slapping these on based on the geometry of this thing, right? Now I have made, there is a way to do it, some systematically, right? A programmer could do it. I made an Excel spreadsheet that's able to do it reliably. Okay, so in this thing here, we're going to figure out that electric field at point P, right? The electric field at point P is going to be, just add these two fields up, right? So positive 122.349 minus or plus a negative 70.769. These are all newtons per coulomb, right? All right, so here we go. Let's see, this guy, the 122 minus this guy. And I got 51.58. Now the fact that it's positive means it's to the right. So 51.6 newtons per coulomb to the right. Okay? So again, your steps are, I think it's good to figure out, before you do any calculations, figure out which way the electric fields are going to be. If it's a negative charge, it'll be toward that charge. If it's a positive charge, it'll be away from that charge. Okay? Figure out their magnitudes. Based on which direction they are, put a plus or minus on them, and then add them up. Okay? That's the steps.